Hi guys, in this video I want to look at how electricity works. Let us start with the basics of electricity. All materials involved in electrical or which make up electrical components such as conductors are made up of atoms. An atom is the smallest particle of a material. It is made up of three particles that are electrons, protons and neutrons. Protons and neutrons are found inside the nucleus of an atom, and electrons orbit around the nucleus of an atom in orbital shells. Electrons in the outermost shell are called valence electrons. These electrons can jump from one atom shell and start to orbit on another atom shell. And also if voltage is applied to a material, these electrons are the ones that flow. Protons and electrons carry charges on them. Protons carry positive charges while electrons carry negative charges. Since unlike charges attract each other while like charges repel each other, the two charges, the negative charges found on electrons and positive charges found on protons are unlike, they attract each other. Since protons are contained inside the nucleus, they can't move. They attract electrons toward the nucleus so that electrons can't jump to other shells of nearby atoms. The degree to which electrons are held by the nucleus of atoms of a material is the resistance of that material. Resistance is measured in ohms. The larger the value of resistance in ohms, the more the resistance a material is. We have three types of materials grouped according to the degree to which electrons are held by the nucleus of atoms. That are conductors, semiconductors, and insulators. Conductors are materials in which electrons are loosely held by the nucleus of atoms. In conductors, electrons can easily jump from one atom shell and start to orbit on another atom shell. These materials have low resistance. They are used to conduct electricity. Insulators are materials in which electrons are slowly held by the nucleus of atoms. Electrons in insulators can't even jump from one atom shell to other shells of nearby atoms. These materials have high resistance. Insulators are used to cover current-carrying conductors, so that when something gets in touch with the cable conductor, current will not flow through it. Semiconductors are materials that lie between conductors and insulators. If we increase temperature to semiconductors, they become conductors, and if we reduce temperature, they become insulators. In electrical, we can vary the resistance of these materials by changing their cross-sectional area, by changing their temperature, and also by changing their length. Since electrons in conductors are loosely held by the nucleus, they randomly move in different directions. To constitute current, electrons must move in the same direction. For electrons to move in the same direction, they need a force of voltage that pushes them to flow in the same direction against circuit resistance. For our electrical components such as light bulbs to work, electrons must pass through them at a certain rate in the same direction. When electrons pass through electrical components, the material making up electrical components will start to behave in another way. For example, this filament lamp. When electrons pass through it, the filament heats up and produces light. Let us have an understanding on current. Current is the flow of electrons in the same direction. Current is measured in amperes using an instrument called an ammeter. To measure current flowing in a circuit, an ammeter is connected in series with the circuit components, so that all electrons that pass through the circuit components will also pass through the ammeter and be counted. The ammeter counts the number of electrons passing through it in every second and displays them in amperes on the screen. 1 ampere is equal to 6.28 quintillion electrons passing through any point within a second in every second. As we have said, voltage is the force that pushes electrons to flow in the same direction against circuit resistance. Let us look at what type of force is voltage. Voltage is a force that is as a result of two different points that are different in electrical potential. For example, the positive and negative sides of a charged battery. The negative side of a charged battery has more electrons than protons, and the positive has fewer electrons than protons. In terms of electrons, since electrons are the ones that move, the negative side has a higher electric potential than the positive. If the two are connected together through a conductor, electrons will flow from negative to positive until the potential difference between the two sides goes down to zero. The potential difference between 2 points of voltage is measured in volts. The higher the value of voltage in volts, the more the force of voltage. Electricity is generated either as direct current electricity or alternating current electricity. Direct current electricity is a type of electricity in which electrons flow in only one direction. It is usually produced by solar panels and DC generators. Alternating current is a type of electricity in which electrons change the direction of flow, or in which electrons flow back and forth due to change of polarity. Electrons always flow from negative to positive. In AC, when polarity changes, electrons also change the direction of flow so that they continue flowing toward the positive polarity. The change in polarity in AC can be caused by moving the magnetic field of a magnet across a conductor, or more easily by rotating the magnetic field covering the conductor coils. When rotating the magnetic field of a magnet, the other side repels electrons while the other side attracts electrons. It looks like the other side is positive and the other side is negative. So when the magnetic field is moved, it will disturb electrons, causing them to move, resulting in current. The coiling of a conductor is to increase the length of a conductor inside the magnetic field so that more voltage is obtained. In direct current electricity, electrons flow in only one direction because there is no change of polarity. Alternating current electricity works at a certain frequency. Frequency is the number of cycles completed in 1 second. A cycle is when the magnetic field rotates back to its initial position. Frequency is measured in Hz, for example 50 Hz. This means that the magnetic field rotates 50 times in every second. Most countries use 50 Hz while others use 60 Hz. Let us look at power and energy. Energy is the total amount of work done or to be done in an electrical circuit. Energy is measured in joules. Energy exists in many forms such as mechanical and electrical. Let us have an example in mechanical. In this example, we want to find out the total energy required to move an object through a distance of 2 meters by a force of 20 newtons. The total energy in this example is found by the product of force and distance, which is 40 joules. Power is the rate at which work is done, or it is the amount of energy used in every second. Power is measured in watts. Like in the previous example, if the time taken to move an object through a distance of 2 meters is 10 seconds, then power is energy divided by time, which is 4 watts. Power shows the strength of one carrying out the job. Unlike mechanical power and energy we were looking at, in electrical we can't see moving electrons or the distance electrons are being pushed by voltage, but the meaning of power and energy is the same. Since power is the amount of work done in every second, it is the same as the product of current and voltage used to push electrons to flow in every second. Since energy is the total amount of work done or to be done in an electrical circuit, it is then power multiplied by time taken for work done in a circuit. Energy is measured in joules or mostly in watt-seconds in electrical. If working with large amounts of energy, kilowatt hours is used. A kilowatt hour is often called a unit in electricity. Most electrical supply companies charge their consumers in kilowatt hours. Okay guys, this is what we have in this video. I hope you enjoyed it. See you in our next videos where we look deeper at voltage, current and resistance.